Is that fine? Okay. Okay. So hi all, I'm Mateo, and this is ongoing work together with Robin, Alex, and Fabio on iteration in discrete probabilistic programming. So in comparison with common programming languages where you evaluate a program and that results in the execution of some routine, as you surely know, probabilistic programs, when you evaluate them, they result on some probabilistic model. Growth of interest in this has led to various different libraries and languages such as Stan, Edward, Psi, or DICE. Last one, DICE, is a functional probabilistic programming languages that allows you to specify discrete distributions and is focused on efficient inference for programs with large number of variables. So on our work, we're interested in adding unbounded inference to such a language. So to give a high overview of what DICE offers to the users, a user in DICE can specify variables, tuples, if-then-else statements with probabilistic guards, Bernoulli distribution, and observations. It also has functions, let bindings, and not in this figure, but also present, you can specify bounded integers and bounded iteration. So a program in DICE can be seen basically as the combination of two weighted Boolean formulas, one that keeps tracks of all the assignations that we have to the flips that you encounter in a program, and another one that also keeps track of the assignations that you put on the flips within a program, but takes into account the constraints that have been put by the observations. This is internally represented with binary decision diagrams, and probabilistic inference is performed using weighted model counting on this and using a weighted formula that keeps track of all the weights of the flips that we've defined so far. So while DICE allows you to define a lot of different interesting programs, while leveraging the expressivity together with the constraints that you must put in order to scale to programs that have a lot of variables, it leaves out certainly interesting things to have in probabilistic languages, such as continuous random variables, and of interest to us, unbounded iteration. So we tackled the problem of bounded iteration by proposing two different forms of iteration which are compatible with each other. The first one is reminiscent of common while loops. So basically, we define a form of iteration that takes some expression t that starts with an initial value of x that is equal to something that the user passes to t, and then it will keep iterating t while consuming some Boolean variable that functions as a guard, g. And in the process, we will keep updating x with the value t of x, stopping whenever g is false. So this works. It's well known since the work of Cousin in the 80s. One problem with this is that its semantics is uniformly zero on diverging executions. So our second form of iteration does not have this problem, and it's basically done by taking the mean ergodic fixed point of some probability expression, again t, that also takes some value x. And it will keep iterating t while taking the increased average of t of x, hence grabbing the Casara limit of the transition kernel that is basically defined by the expression t that we're iterating. So not mentioned in these slides, but also interesting to us, is how can we integrate this with DICE implementation? We already have some results in this. What's the relation between the proposed forms of iteration? What are relevant use cases? And what are the convergence times of the two forms of iteration that we are proposing? Thanks. And if you have further questions or want to talk more about this, you can find me at the poster session.